Now, we have arrived at the hands-on section that we've all been looking forward to. Before we start, let's review the case scenario. We won't go into the background for now. Let's take a look at what analyses we need to do. We can see that the main tasks are the calculation of 3 different types of scores, including comprehensive quality scores, the classification of grades for each class, the analysis of the average response time of students, and the distribution of exam times. Actually, these analyses have already been mentioned in the previous explanation, so now let's start operating in FindBI. After entering the project, the first step is to click to create a new analysis subject. Here, we choose Local Excel Data, and select all sheets to upload all the tables at once. For the sake of demonstrating the merging feature later, let's not merge the tables into one just yet. We'll do the merging manually later. After entering, the first thing we do is to adjust and simplify the data structure, as we discussed earlier. We will start by splitting the 3 course scores that are bound together into separate rows. We begin by splitting the rows and breaking apart the scores for the 3 subjects. Now we can see that each subject has been separated into its own row. But that's not enough yet. Let's continue splitting. Next, we'll separate the subject and grades. We'll split based on the space. Since we need both the subject and the grades, we select the first 2 columns to keep both results. Now we see the effect. However, notice that the exam results are in text format. In fact, the scores should be numeric since we'll need to perform calculations. We click on the table header and change it to numeric format. Now, let's not rush forward yet. Let's do a bit of field setup and remove any content that could interfere with our analysis, such as the intermediate results from splitting the exam results and the first split result. We'll uncheck and hide them. Also, we will rename the existing field to grades for better management. Next, we continue adjusting the structure of the table since it's still not very easy to read. This is where the rows to columns function comes in handy. We'll pivot the subject and score into columns. After selecting them, we can see the result. At this point, we can clearly see the scores for Chinese, Maths, and English. Next, we need to handle duplicates. Currently, the data is small, so we can easily spot duplicate names, like Li Ming and Zhao Lei. If the data were larger, we could click the drop-down arrow to automatically calculate the number of unique records. We can see that Li Ming has 2 records, indicating that there are duplicates. To figure out how the duplicates occurred, we filter out Li Ming's records. After filtering, we can see that Li Ming submitted 2 times, which is the cause of the duplicates. According to our rules, we'll keep the most recent submission. So, we need to remove the duplicate entry. To do that, we first sort the records to make sure the most recent one is on top. We sort by name first and then by submission time, in descending order, so the latest submission comes first. After checking Li Ming's data, we confirm that the latest submission was at 6 p.m., while the earlier one was at 4 p.m. With this confirmed, we can now remove the duplicate row. We choose to remove duplicates based on the name field and confirm. After removing duplicates, we move on to handle missing values. First, we address the missing names, which we definitely don't want. We can filter them out by selecting name and keeping only non-empty values. That's done. Another situation is when the score is missing, which indicates that the student missed the exam. We can add a new column called absent mark to label these students. This works fine, and we've completed the flagging process. Now, let's pause and consider, wait, we've only processed the data for one class. What about classes 2 and 3? We notice that the structure for the scores in Class 2 and 3 is also problematic. Some might suggest that if we had merged all the tables initially, we wouldn't be in this situation. But we don't need to redo all the operations for Class 2 and 3. Instead, we can use the History step area to insert a step and go back to the beginning to merge the data for these two classes. We choose Union All and match the corresponding fields, such as submission time. Now, the tables are merged, and the steps are applied to all classes. Now, we can move on to add additional data from the student information table, including age, class, sex, and comprehensive quality scores, broken down by sports, fine arts, and social practice. We'll merge these with the main table using join. By selecting all the data, we match them by the common name field. Since there are no students with the same name in different classes, the merge process works without any issues. Next, we want to add the comprehensive quality scores. We will sum up the scores from the corresponding table using the sum function and match them by name. After adding the scores, we can verify by checking the data for Li Ming. We see that his total score is 84, which matches the sum of 29 plus 22 plus 33 from the previous table. We can proceed with field settings, renaming the field to comprehensive quality. After adding the required data, we've completed two tasks, adjusting and simplifying the data structure and merging tables. Now, we need to add our analysis indicators. First, we calculate the three scores by simply summing the Chinese, Maths, and English scores. We add a new calculated column and name it Sum Scores. Next, we classify the scores into different levels. We start by creating a tag for Chinese scores, using a conditional tagging function. We set up the conditions for different levels, excellent, good, pass, and fail, based on score ranges and absent marks. Finally, we calculate the average response time by subtracting the exam start time from the submission time. We use minute as the unit, since hours would be too coarse. We can check if any response times are unusually long, like 1,450 minutes, which seems impossible. After reviewing the situation, we discover that the student took the exam on July 1st but submitted it on July 2nd, which could be an error. Next, we use getTime function to calculate the starting hour of the exam. We also analyze the exam start times and find that most students started around 10 a.m. or so. At this point, we've completed the required analyses. Of course, in a real analysis, we'd need to visualize the data for better insights. That concludes the course on data editing. I encourage everyone to review the course materials and complete the assignments to reinforce what we've learned.